Hello students. So every year when I check the papers of algebra, I come across some very common mistakes while calculations. So in this video, we will look into those silly or common mistakes which are simple, but still there is confusion which every one of you should know. So before I start, my name is Santanu Das and I've been teaching from the last 27 years. Let's begin with the video. Suppose you are given something like this 2 plus minus root 8 upon 4. Now, this root, whenever the number is big, greater than, if it's not a prime number, you need to first factorize it. Now, in this case, it's 8. So, when I factorize it, I get it as 2 4s are, 2 2s are, 2 1s are. So, the factors of 8 is going to be 2 into 2 into 2. So as it's a square root, so this 2 will be a pair and this don't have a pair, so it will be in the root itself. So what you are going to get is 2 plus minus, and this is a pair, so it will come outside, and this do not have a pair, so this will be written this way. So basically what I wrote is root 8 in the form of 2 into 2 into 2. Now as square root, we need to take a pair of two terms. So this is going to be, this 2 will come as 1 2 and 2 root 2, which I have written it down upon 4. Now as you can see, 2 is common in them. So we are going to take out 2 common. So when I'm going to take out 2 common, nothing is here. So I'll write it as 1 plus minus 2 is been taken out common. So it is going to be root 2 is remaining. So upon 4. This is how we take it out common. Those who find it confusing, see how I took out the common is 2 means 2 into 1 and 2 root 2 means 2 into root 2. Now common, 2 is common in both the terms, so that I wrote it outside. Then I put a bracket and in this 1 is left, so we have written 1. Then there's plus and minus, that I wrote it down, and in 2 root 2 is left, so that I have written bracket 4. So bracket root 2. So upon 4, now we can cancel this. 2 1s are, 2 2s are. So the final answer is going to be 1 plus minus root 2 upon 2, which means 1 plus root 2 upon 2 and 1 minus root 2 upon 2. When you are cancelling, you can cancel when there's a multiplication in between. You cannot cancel year and year or year and year because there's a plus sign in between. Cancellation means division can be done only when it's in the form of division. So that's how it's done. Let's take another example. Say I give you minus 6 plus minus root 343 upon 3. So whenever you see a number big as this, what we'll do is, let's factorize it. So 343 no, let's take it, say 243. So 243 69, it will come in 3's table. 3 8s are 24, 3 1s are 3, 3 27s are 3 9s are 3 3s are 3 1s are. So the factors we got is 3 into 3, 5 3s into 3 into 3 into 3. So square root, we are taking the square root. So this 2 will be one pair, this 2 3's will be one pair, and this do not have a pairing, so it will be inside. So the answer is 9 root 3. So this can be written minus 6 plus minus 9 root 3 upon 3. So you don't cancel directly this and this or this and this because there's a plus minus. So first, if anything can be taken out common, we need to take it out common. Now, how can we take out common over here? Same thing. If you are good enough in understanding that this 6 and 9 comes in 3's table, you do it directly. But if you are confused, you don't understand it directly, just write 6 can be written as 3 into 2 into 1, and 9 root 3 can be written as 9 is 3 into 3 into root 3. So 3 is common in them, both of them. So I'm going to take out 3 common. So what is left is 2 ones are 2, and the minus sign, don't forget to put the minus sign, plus minus, what is left is 3 root 3. Write this down upon 3. So don't cancel this because there's a plus minus. This 3 is in the multiplication form, so you can cancel this. So the final answer is going to be minus 2 plus minus 3 root 3, or it's minus 2 plus 3 root 3 and minus 2 minus 3 root 3. Okay, so this is a set of questions where confusion happens. Another example is, suppose I give you some division, okay, say 24.345 divided by 3.7. Now you can't cancel when there's a decimal in the denominator. Decimal in the numerator is fine, but if there's a decimal in the denominator, first you need to take out that decimal point. How do you take it out? The decimal is after one place, so we need to multiply by 10. If the decimal was after two place, I would have multiplied by 100. Now when we multiply by 10 the denominator, we need to multiply 10 the numerator also. If I would have multiplied the denominator by 100, then I would have multiplied the numerator also by 100, so that the meaning of the value of the sum doesn't change. Now whenever you multiply by 10 or 100 or 1000, or you divide by 10, 100 and 1000 or 1000, the confusion is students wonder, where should I put the decimal? I should take the decimal to the right hand side or to the left hand side. So there is a very simple logic by which you can remember, that is, see, whenever we multiply, I hope everybody knows it, the number becomes bigger, and whenever we divide, the number becomes smaller. So in this case, just imagine, just wonder for a moment that you don't know where to put the decimal, but as it's multiplied by 10, the first thing you think, maybe I have to put the decimal to the left. Then what will this number become? This number will become 2.4345. So the original number was 24, and now the number has become 2.435. That means the number has become smaller. Now you use your sense, your logic. How can the number will become smaller? Because you are multiplying it by 10, so it should become bigger. So that means what you are thinking is wrong, and the decimal will not come to the left, it will move towards the right, and what you'll get is 243.45, and here also decimal will move to the right, so 37. And then you divide the thing. I hope everybody knows how to divide 37 to 43.45. The first one digit, it's not divisible. Two digit, it's not divisible. You have to take three digits, so you just divide it. 37 5s is going to be 7 5s are 35, 185, smaller than 243. Let's take the next number, 37 into 6, 7 6 are 42, 6 3s are 18, 222, still smaller. So let's take the next number, 7 7s are 49, 7 3s are 21, 259, it has become bigger, so we'll divide it by 6. 7 6 are 42, 2 2 2, 1, 4 minus 2 2, and 4. Now there's a decimal over here, so you are going to put a decimal here. So now the next number, 214, 222 is bigger than that, so you have to by 5. 5 is going to be 7 5s are 35, 3s 5 3s are 15, 185. Subtract 14, 9, 0 can't be, so you have to borrow 1. 10 minus 2, 20. Bring the next number down, 295. 295 bigger than 259. So let's try by 8s are 8 7s are 56, 5 8 3s are 24, 296. So the number has become greater than this, so I have to take 7s out itself. 7s it's going to be 259, 5 you can't subtract, so you have to borrow 9. You have borrowed 1 from here, so this will become 8, 6, 3, 6. Okay, now you always find till 3 places, okay, and then we'll write the answer. So now from my mind I'll write 0. So I got 360, it's 296, 8s are, no? So let's check 9s are, 9 7s are 63, 9 3s are 27, 3 3 3 smaller, so it's going to be 9, and that's going to be 3 3 3. So one borrow from here, 5, so 7, 27. So the answer we got it as 6.579. You always find till 3 places. Now if the third place number is 5 or more than 5, you add 1 to this, and if it is less than 5, you keep it as it is. Like for example, in this case, the number will become 6.58. You have added 1 to it because the third place number is more than 5. Just imagine if it was 4, then I would have written the final answer as 6.57. I wouldn't have added 1. So this is how you will solve the sum. In case this sum was given, the same sum was given in the form of 2.345 upon 37. That means the first step that I did of removing the decimal point from the denominator, that is not needed to be done, but the rest of the sum has to be the same. That is, I'll do just the beginning part, 37, 2, 4, 3, 4, 5. See the difference now. Now it's not divisible by 2, 4, so you have to write a 0 over there, and next you have to take those 3 numbers, and when we take 243, it is 6, and the rest will be the same thing. So in that case, if there was no decimal over here in the denominator, my answer would have been 0.657. And as you see, the third place number is more than 5. So again, I would have written the answer as 0.66. This is how we would have written the answer. Next example, 1 upon 10 plus 3 upon 10. Very simple, very basic, but still students make mistake. See, in case of fractions, when you're solving fractions, denominator should be same. And when the denominator is same, you don't add the denominator, you write it as it is. And you add the numerators. That is, 1 plus 3 is going to be 4 upon 10. Okay. Students add this also, 10 plus 10, they write it 20. Or 10 into 10, they write it as 100. Don't do all those things. In case of plus or minus, you will keep the denominator as it is. Okay. Another example. Suppose I had given 1 plus 3 upon 10. Okay, again, what many students do, they just write it 4 upon 10, which is absolutely wrong, because this was a number and this is a fraction. So you don't solve this way. What you need to do is, there's no number over there, so you have to imagine there's 1 over there, there is 1 over there, so you just write it and then cross multiply. Okay, so 10, and how do you cross multiply? This by this, this by this, and this by this. So 10 ones are 10, plus 1 3s are 3 upon 1 into 10. Again, don't cancel over here because there's a plus sign. You need to solve it, and you will get it as 13 upon 10. So this is going to be the answer. Next, suppose I give you two numbers, 2 upon 5 minus 3 upon 7. This time their denominators are not same. So then what do you do when the denominators are not same? Then again the same thing, you need to cross multiply. First you always cross multiply this part. So it's going to be 2 7s are, that is going to be 14. Then you multiply this and this. There's a minus sign, so put the minus sign in between. 5 3s is 15. Okay, I just my voice may not be sounding good because I have a little bit of cold, so excuse me for that. Okay, So 5 sevens is 35. So what we did was first we multiplied this and denominators we multiplied, just like in this example. So whenever you are multiplying two fractions, or when you are adding or subtracting two fractions, the denominators needs to be same, then you write it as it is. If it is not same, you cross multiply. In this also it was not same, so we cross multiplied. In this also it's not same, we cross multiplied. Now we'll solve it. Plus minus is minus, 15 minus 14 is 1. Put sign of the bigger number, 15. So it's minus 1 upon 35. So this is another example. Next is, in the Cramer's rule, suppose you are given something like this: minus 1 upon 2, 3 upon 5, 3 upon 2, and 5. So how will you do? In Cramer's rule, first we multiply this two, that is minus 1 upon 2 into 5. There's a minus sign. We always put a minus sign in between. Then we multiply this two. That is going to be 3 upon 2 into 3 upon 5. Okay. To make this some more confusing, let's put minus sign over here. So it's minus 3 upon 2 minus 3 upon 5. Now, in case of multiplication, if anything is cancelable, you cancel, or you just multiply numerator by numerator and denominator by denominator. You don't need the denominators to be same as in case of addition and subtraction. So how we'll do is 5 ones are 5 and 2, nothing is here, 1, 2 ones are 2, and minus plus is minus. Same way, put the minus sign. Same thing over here, 3 threes is 9, 2 fives is 10, minus minus is plus. So it's understood. So see the difference. Here, we did not cross multiply because there's a multiplication. While in this example, we cross multiplied. So those students who are really weak in maths and their basics are not clear, they get confused. Even in addition, subtraction, they cross multiply, and in multiplication, they sit and cross multiply. So you remember this. In case of multiplication, denominator don't need to be same. You just need to multiply the numerators and the denominator. In case of addition and subtraction, the denominator needs to be same. So you need to cross multiply. So here, what do you get? So you have minus 5 upon 2 and minus 9 upon 10. Cross multiply. Now this time it's addition, subtraction. So in addition, subtraction, what do we do? What we did here, that the denominators are not same, so we'll cross multiply. Minus 5 into 10 would be minus 50. 2 into minus 9 would be minus 18. And 2 tens are 20. Now don't sit and cancel this because they are subtraction. So minus 50 minus 18 is minus minus plus. So that's 68. It's 20. Both are divisible by 4. 4 5s are 20. 4 1s are 4. 28. 7s are. So the final answer is going to be minus 17 upon 5. Okay. Next example. 3 plus 2 upon 2. Very basic. I know you did it in your 4th standard, 5th standard, but still mistakes are made. This kinds of sums, mistakes are. Now you have 3 plus 2 upon 2. What students? They just cancel this and write the answer as 3. This is wrong. You can't cancel because there's a plus. Even if there was a minus, you couldn't cancel it. What you need to do is 3 plus 2 upon 2. You first need to add this. That is going to be 5 upon 2. That's how you need to do it. Next mistake. 3 upon 2 divided by 2. Again, 2 ones are 2 ones are. Answer is 3. This is wrong. This is not the way to do. 3 upon 2 divided by 2. Now, division you can't solve it. First, you need to make it a multiplication. So how do you make it a multiplication? There's nothing written. So in the denominator, there's a 1. So it's 3 upon 2 into 1 upon 2. Now, this is an example of multiplication, not a division, not addition, subtraction. So you just multiply. 3 1s are 3, 2 2s are 4. So answer is going to be 3 upon 4. Next example. x minus 2 upon 3 is equal to x plus 2 upon 5. Now, as you can see, there's one term on the left hand side and one term on the right hand side. In that case, you can cross multiply and write this as 5 bracket x minus 2, 3 bracket x plus 2. This goes here, this 3 comes to the other side. So this will become 5x minus 10. You have to multiply both of them. Students just multiply the first term, they leave the second term. That's wrong. 3 into x is 3x, 3 into 2 is 6. Now variables, you always bring it to the other side. So 5x, 3x, when it comes this side, it will become, it's plus 3x, so it will become minus 3x. Minus 10 is equal to 6. So that is 2x minus 10 is equal to 6. Now one by one you have to take the numbers. So first, always you have to take this number. Means whatever is with x, you have to take it last. So 2x, first 10 will go that side, minus it will become plus. I made a separate video on this topic, okay? Please check out the video. You will understand it in details. 16. So x, it's a multiplication, and it goes to the other side, 16 upon 2, that is 8. So this is how you will solve it. Now, see, little change in the sum. Suppose I had given you sum like this, x plus 2 upon 3 is equal to x upon 5. Now, in this also, students, what they do is just like this, they cross multiply. They write 5, do some kind of wrong steps. Now, see, in this case, we could cross multiply because this is one term and this is one term. So we could cross multiply. Here, this is one term, this is two terms. So in one left hand side, there are two terms, on the right hand side, one term. So then you can't cross multiply. So in that case, what you need to do is you always take the LCM of whatever is in the denominator. In this case, there is 3 and 5. Take the LCM of 3 and 5. 3 ones are, 5 is not divisible. 5 ones are. So the LCM is 15. So whatever the LCM is, multiply. So LCM of 3 and 5 is 15. So multiply by 15 to both sides. So when you are going to multiply by 15, so whenever you see numbers like this, you multiply every number by that LCM. So when I'm going to do that, what I'm going to get is 15 into x is 15x, 3 5s are plus 10 is equal to 5 3s are is equal to 3x. So 3x comes this side, 15x minus 3x, and 10 goes to the other side, so plus becomes minus 10. So 15 minus 10 is 12x is equal to minus 10. Now x would be minus 10 upon 12, that is 2 5s are, 2 6s are. So the final answer is going to be minus 5 upon 6. So see the difference in this sum and this sum. Although the difference is minor, but as the difference is not known by many students, they try to solve both the sums in the same way and they'll end up doing it wrong. So I try to understand the difference, okay? Next, suppose I give you 37.5 minus 0.25. Okay, so how students subtract is 0.25. Now this is wrong. Whenever you are subtracting, whenever you are adding, unit place will be under unit place, tens place under tens place, 1 upon 10 place upon 1 upon tens place. So in this case, 37.5, in this 5 is 1 upon 10 place, and 0.25 in this 2 is in the 1 upon 10 place. So how the number will be written is 0.25. Now I purposely have taken a subtraction sum because subtraction is more challenging. Addition, you could have directly done it, but in case of subtraction, you need to write a 0. The good habit is to write 0 every time, no matter whether it's a plus or minus. And now you subtract. How will you subtract? 0 can't be subtracted by 5. So we'll borrow 1 from this 5. So it will become 4. 10 minus 5 is 5. 4 minus 2 is 2. 7 minus 0 is 7. 37.25. Suppose the sum was 375 minus 0.25. Again the same thing. 375 375. In this, 5 is the unit place, 7 is the tens place, 3 is the hundreds place. In this is 1 upon 10th place. So you don't write below any of this number. It should be 0.25. So when you are going to subtract it, before that you need to write 0 over here, and now you subtract. While subtracting, first time we write a 1 over there because 0 can't be subtracted from 5. So we assume that this is 10, so we have borrowed from here, so this will become 9. But every time any number becomes 9, because this doesn't have any number, so we have to take it from the next number, that is, this will become 4. So you, whenever the number 0 becomes a 9, you go on borrowing from the next number. So just imagine if this was a 0, again it would be 9, and you continue till a normal number, till you get a natural number from where you can borrow. Like for example, here it has become 9, so I have to borrow from the next number, and it has become 4. So 5, 9 minus 2 is 7, 4, 374.75 is the answer. Another example. Suppose I give you 2 root 2 square minus 3 into 2 root 3 into minus 1. So 2 root 2 square is actually 2 root 2 into 2 root 2, and this is 3 into 2 root 3 into minus 1. So see, 2 2s is 4, and root 2 into root 2 is 2, because root 2 into root 2 is root 4, and root 4 is a perfect root, that is 2. Just imagine here you had root 3, that is root 2 into root 3. Suppose the question was root 2 into root 3. In that case, it will be root 6. Okay. Suppose you are given something like this, root 2 into 3. Don't write it as root 6. You can't multiply a number and root, then the answer would be 3 root 2. So remember, roots can be multiplied by roots, means the same kind of root. Number can be multiplied by number. So in this case, 2 into 2 was 4, and root 2 into root 2 is root 4, that is 2. Same thing over here, 3 2s are 6, 6 1s are 6, and root 3. We will not multiply this root 3 with 6 and write it as root 18, okay, or just 18. We have to write it as separately. 3 2s are 6, 6 1s are 6, and root 3, and minus plus, no sign, so minus, and minus minus plus, so the answer is 8 plus 6 root 3. Now again, see, what students do is they try to add it. You can't add them because they are not like terms. You are not going to write this as 14 root 3. That is wrong, because here this has got a root 3, this doesn't have a root 3. So they are not like terms. So only when they are like terms, you can add them or subtract them, whatever is the operation. So these are the few types of examples where students make mistakes most of the times. So I have solved it and explained it in details. You have any other doubts, you can ask me, and if it has been useful, do share with your friends and the students who are in 10th and who find maths weak, who are weak in maths, so that they can also be benefited. And thank you for watching the video.